Lake habitats, such as the lake we're next to today, go through an annual cycle. This cycle involves two periods of stratification, a summer stratification and a winter stratification, and two periods of overturn, one occurring in the fall and one occurring the following spring. We're going to talk about all of these cycles, both stratifications, both overturns. Today we want to introduce our topic on the Ashokan Reservoir, discussing summer stratification. Of course, this is what you're probably most familiar with because most people have their aquatic activities associated with the summer season, fishing and especially swimming. When you swim, if you do any diving down from the surface, you'll know exactly what I'm talking about in terms of temperature change, a topic we'll be getting to in a few moments. Summer stratification occurs because of major temperature differences that occur from the surface of the lake down to the bottom of the lake. First, the lake has to be deep enough to stratify, and we'll get more specific about that in a moment. But most major lake habitats certainly have the amount of depth that's necessary for this stratification to occur. Now, when we use the term stratification, remember that that's an expansion of the word strata. Strata suggests some type of layering within the lake, and that's exactly what occurs. The lake, because of temperature differences, divides itself up into basically three different layers. First, what causes the temperature differences? Well, one of the light rays we talked about previously, one of the wavelengths, that is the infrared wavelength, provides heat for our planet and provides heat for lakes as well. But those infrared wavelengths, as you recall, are filtered out very rapidly so that the heat that is sent down into the lake during summer stratification only enters the first few meters. As you get deeper below the surface, these infrared wavelengths are filtered out. Therefore, no heat is entering the lake, so the temperatures can start declining rather rapidly. And of course, this sets the whole stage for the stratification. Why do these layers become stratified? In other words, how do they separate out? Well, if you remember back to when we talked about the properties of water, we said one of the unusual things about water was that as temperature changes occurred, this causes major changes in the density of water. That is, in this case, the temperature declines as you go deeper. The density also changes drastically. It becomes more and more dense. Therefore, with a rapid change in temperature and a rapid change in density, this blocks mixing. In other words, regardless of how much wind action, whatever, where there is a rapid temperature change, mixing simply can't occur. And that's how you end up with these three strata or these three layers.